Now today's topic is permittivity and relative permittivity, that is also known as dielectric constant. So how we understand the permittivity? Let's come to this one, that we know that the force, Coulomb force, is equal to K Q1 Q2 by R square. But it says that the force, Coulomb force, that is the product of the charges Q1 and Q2 directly proportional to the charges Q1 and Q2, and the force is inversely proportional to the square of the distance between them. What about this K? That K is the constant proportionality. K is the constant of proportionality, called, that is also known as Coulomb, or it is known as the Coulomb constant. Coulomb constant, or it may be written as it may be known as the dielectric constant. Dielectric constant. Sometimes it may be written as relative permittivity. So what about this K and how this K changes? We know in case of the gravitational force, the G will not change, that is the universal gravitational constant, and its value is always everywhere is the same, that is 6.6 into 10 to the power minus 11 Newton meter square per kg square. But here the value of the K changes according to the medium. If that means that dielectric constant or the Coulomb constant varies according to the medium or the nature of the medium. How we come to know? That means in the particular, if we consider the 2-point charge, that is the Q1, and another point charge, that is the Q2, and this 2-point charge will be placed in any medium. There is the medium. Medium have many things, means the medium will be affected by many physical other quantities like pressure, density, temperature, and other maybe. Here we will discuss about the special characteristic of the medium, and that is called the permittivity. Medium itself observe or itself use some of the lines of force, that means that accept or observe that lines of force and allow some of the lines of force, and that means the force will reduce. As we learned in the earlier classes, that whenever the medium, the charges will place in a medium, on that case the force will reduce. How it is so? Suppose there are the number of lines, these 4 lines are moving to that of the charge Q2. But there is a medium, that medium will also accept the sum of the lines, that these lines are observed by the medium. And some of the lines will move to that of the second charge. That means the force what was earlier, that F0 or in air, that force now in a medium, the force will change. And since the sum of the effect is observed by the medium itself, that means it reduces the effect of the force which act over the another charge, or one charge to the another charge. And that characteristic of the medium is known as permittivity. That means medium itself permit some of the electrical lines of force, some of the such type of character which produced by the two charges. That itself to accept this one is known as permittivity. Now for that, and it is permittivity is represented by epsilon of the medium. Epsilon, that is epsilon. And that permittivity, just we come to know that the self acceptance of the some electrical behavior by the medium is called permittivity. That means that the force whatever earlier, or the force is greatly affected by the epsilon. That means if the epsilon will increase, the force will decrease. Now we must understand the absolute value of the permittivity. That absolute permittivity, what is the absolute permittivity? Here we come to know that the permittivity is related with the medium, it related with the nature of the medium, it related with the characteristic, one of the characteristic of the medium, that it self-accepted, it self-observed some of the electrical nature of that force developed by the charges. So on that case, we come to know that if the permittivity will increase, that means the force will decrease. So this shows that now force will decrease. That means it has a relation that K is equal to, we know that the charge, the magnitude of the charge is constant, the distance among this is also constant. We have the earlier relation that F is equal to K Q1 Q2 by R square. That means this 2 is not affected, this 2 is the same. The value of the charge will not going to change. The position also we considered, the distance also which we consider is the same. That means what factor is responsible for the change of the force, and that factor is the K. So we consider that K, and we just come to know that the epsilon is the factor which change the nature of the force. So on that case, we come to the conclusion that K is equal to 1 by 4 pi, that is another constant factor to make it, and that is epsilon. Now this relation gives the constant value for the medium. If it is in air, that is in medium. If it is in air, on that case K is considered as the 1 by 4 pi epsilon naught. And we know that the value of the epsilon naught that we have calculated in air, the value of the epsilon naught, and that is equal to 8.854 into 10 to the power minus 12. That means here we will use the epsilon naught here. On that case it is Coulomb square per Newton per meter square. So this value we will study in the higher classes how it comes, but here we have the relation, we have the value epsilon naught in air, that is the 8.854 into 10 to the power minus 12 and such, with the unit Coulomb square per Newton per meter square. Now if we consider this one with the relation and we put this one here, on that case 1 by 4 pi, pi have the constant value, that is the 3.14 into 8.854 into 10 to the power minus 12, and on that case we have the relation, and this will above the unit Newton meter square per Coulomb square. So we get the K value of the K in air, that is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. That is the value of the K in when two charges are placed in a vacuum or air medium. Both that K value we have. But what we come to the conclusion that if the medium will be there in place of the air, on that case epsilon will change, that means the K will change. Or the K will change, so on that case the force will change. K is the dielectric constant you may say, Coulomb constant you may say, or relative permittivity you may say, that is the proportionality constant will change, that affect the force. this point we come to know. Now, one more thing, that what about the absolute value of the permittivity? Absolute permittivity for the medium is the, suppose there is some lines and out of that 60 lines is observed by the medium. So total, if we consider in air, that is the epsilon naught. On that case, absolute value of this one is the 60, that is the numeric value, or we can say that the quantitative value of this one, and that epsilon 60 into this much epsilon naught, we will only the 60 moves, that means 40 if 60 is observed, that means the 40 will reach here. 40 lines of the force or 40 character will reach to the Q2. So on that case, if we consider that epsilon naught is equal to how much it is, that is the 8.854 into 10 to the minus 12 in air, that is per Coulomb square per Newton per meter square. And if we consider that 60 will be observed and the 40 remain, on that case we will write this one, that epsilon naught minus how much will reduce, that is the 60 of epsilon naught or percentage of epsilon naught, and that will give the 40% of epsilon naught. That is the relation, and if the number of the 40 will multiplied with the epsilon itself, then it will be the absolute value. If we see, if the 40 will have multiplied, or we can write it as, that is the 40 of epsilon, that means we give the 40 into 8.854 into 10 to the power minus 12, and whatever the unit is here, that is Coulomb square per Newton per meter square. This will give the absolute value of the medium, absolute value that will reach to that of this one. And if we consider about the medium, so on that case medium will expect how much it will expect observe, that is the 60%. So on that case, medium epsilon is equal to, we may write as a 60 into 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. What it shows, that is the absolute value of the permittivity in a medium or of a medium. So we come to know that this becomes the absolute permittivity of the medium, whereas epsilon naught is the, this one is the absolute permittivity in air. So we come to know that whenever some mathematical relation, some quantitative value, what the observed by the character, that is the medium, that is the electrical lines of force, that much when multiplied with the absolute value of the air, it will give the absolute value of the medium. So that also relate the relative permittivity or dielectric constant. So for what we come to know, what we now have the conclusion, that first of all the permittivity, the name of the word permittivity, that means it shows how much the lines, electrical lines, are observed by the medium itself is known as permittivity. What about the absolute? When it is multiplied with the 8 into 10 to the power 8.854 into 10 to the power minus 12, that is the absolute permittivity of air or the vacuum. When multiplied with the how much it observed, it will give the absolute value of the medium or permittivity of the medium. That is the absolute nature of this one. Now we will discuss about the relative permittivity or dielectric constant. See, when two charges are present, two charges, let it be the point charge Q1, another point charge Q2, when there is a medium is air in between and it has a separation of r distance. On that case, according to the Coulomb, we have the force in air between the two charges is the 1 by 4 pi epsilon naught. That is the absolute permittivity in air, and Q1 Q2 by r square. That is the equation number 1. Now the same charge at the same distance when placed in a medium, when same charges at same distance apart, same distance apart is placed in a medium, then the force is given as F in the medium is equal to 1 by 4 pi epsilon, that is absolute permittivity of the medium, Q1 Q2 by r square. So on that case, this will become the equation number 2. Now if we divide the 1 by the 2, dividing 1 by 2, we get what? That f of the air by the f of the medium. And if you write this thing, that is the 1 by 4 pi epsilon naught Q1 Q2 by r square by 1 by 4 pi epsilon naught Q1 Q2 by r square for the medium. So on that case, we have only this epsilon will move upward, epsilon by epsilon naught, and this relation gives the relative permittivity, or we may write that is the epsilon r, or we may write epsilon f a by f medium, f air by the force in air by the force in medium, that equal to the epsilon by epsilon naught, that is equal to the relative permittivity, or we may write as a k, that is the dielectric constant. What we come in this conclusion? That here the permittivity, relative permittivity is the ratio of the force among the two charges at a distance of a constant distance when placed in a air to that of the force between the same two charges at the same constant distance. That ratio is known as the relative permittivity or dielectric constant. So relative permittivity, from this relation number 3 we come to know that epsilon means the permittivity of the medium is equal to epsilon r into epsilon naught. If we consider the medium f of the medium, that is equal to 1 by 4 pi epsilon Q1 Q2 by r square. On that case, in place of this epsilon, we may write this one. So f medium is equal to 1 by 4 pi. Here it is epsilon naught into epsilon relative permittivity Q1 Q2 Q1 Q2 by R square. So here that means we will write it as a F of the medium to F of the air by the epsilon. Or you may find the same relation, that is the relation number 3, that is it is the ratio between the force in air to that of the force in medium, is known as the relative permittivity, or the absolute value of the permittivity in a medium to the absolute value of the permittivity in a air is the relative permittivity, or it may be written as the K as the dielectric constant. So all about this, the relative permittivity and the relative permittivity. So we come to the conclusion that whenever the permittivity will increases, on that case the force will decrease. Force among the two charges, force between the two charges will decrease. Why it is so? In the beginning we come to know that the permittivity stands for the medium. If that means the medium itself accepts some of the electrical nature due to the electrical force, due to the charges, and that's why the force will decrease. So we have the relation, that is the force is inversely to that of the absolute permittivity of the medium. So this all about the permittivity and the absolute permittivity.